These comets can be many miles across, and they're moving extremely rapidly, sometimes as much as 100 miles per second. This makes them pretty dangerous. How dangerous? Ask a dinosaur.
Some people think that the massive impact that killed off the dinosaurs may have been caused by a huge Oort cloud comet. They can be far more dangerous than the asteroids usually blamed for extinction events.
Comets are falling from so far away that in general they're moving faster than asteroids, and their impact energies are that much larger. Even something as small as a mile or two across could cause a lot of hurt. But a lot of these Oort cloud comets that come into the inner solar system are very large. And you can imagine if one of these things is 30 or 50 miles across, this would be a global event.
We'd have little or no warning, because we have no idea what is hurling stuff out of the Oort cloud at us. Our distant adversary could be the solar system's best-kept secret, a sinister twin to our own sun, a second star inside our solar system, our nemesis. We've now extended our theoretical knowledge of the solar system to around 9 trillion miles past the planets, but we're still working in the dark.
Carl Sagan said that we're in the age of Magellan. We're not in the age of Columbus. What does that mean? That means that we know the basic outlines of our solar system. We know the planets. We know there's a Kuiper belt and an Oort cloud. But we don't know the details. We haven't actually visited each one of these places, and we don't know the geography. So we're really filling in the map right now.
We've worked out there are around 2 trillion objects in the Oort cloud, a sphere of junk left over from the formation of the solar system, and that every now and then, one of them comes hurtling in towards us.
A big question is, why would one suddenly decide to come in? What is perturbing them? What's poking them so that they fall in and approach the inner solar system? Well, there are a lot of different ideas of what it could be.
Some find clues in the series of catastrophes that nearly wiped out life on Earth.
There appeared to be, in the fossil record, a periodic series of mass extinctions roughly every 26 million years.
It seemed something was jostling the Oort cloud, periodically spraying comets, which opened up a wild possibility.
When we look out at stars, we notice that most of them occur in binary pairs. In some cases, they can be very far away. They can even take millions of years to orbit each other. So the question seemed sort of natural. Does the sun have a companion that we haven't found yet because it's so far away?
It's fascinating to think about whether our sun may have a brother or sister currently, because we know that more than half the stars in our galaxy, 100 billion strong, are in binaries or trinaries or quaternary systems. So actually, a lone star is a little exceptional.
And could this distant star be responsible for disturbing the Oort cloud?
What would happen is that every 26 million years, this binary star partner would pass through the Oort cloud, upset orbits, and send comets streaming in all directions, and some of them would come into the inner solar system, strike the Earth, causing a mass extinction event. And the name of this really dangerous binary star partner of the sun was Nemesis. Ooh.
The Nemesis theory has its problems. Certainly the gravity of a mysterious star passing through the Oort cloud could periodically send comets raining down toward the sun and Earth. But if our sun has a companion star, it should be visible.
So you think, of course, this Nemesis star should be very easy to see because, after all, stars are bright. But the idea here is maybe Nemesis is a dwarf star. Maybe it's a round dwarf. So it'd be really small, and therefore it would not be very bright.
A brown dwarf isn't a star or a planet. It's something in between, a failed star that never got started. Stars ignite when gravity crushes vast clouds of hydrogen gas together, generating huge pressures and temperatures. If there's not quite enough gas, though, there's not enough gravity to light a nuclear fire.
So it doesn't become a star. On the other hand, it's much bigger than Jupiter, which is only 1/1000th the mass of our sun. These objects heat up, but never go boom like stars do. They're difficult to see because they're very dim, but they could contain a significant amount of mass.
Is there a brown dwarf somewhere out there that nudges comets towards us at regular intervals? A brown dwarf this far out would be too dim for us to see, but it should be hot enough to find using infrared.
With infrared telescopes, you can pick up the heat of something, even if it's not giving off any light. So something like a brown dwarf, even though it's not glowing in visible light, should be giving off a lot of heat.
There have been missions which have surveyed the whole sky, and if there had been a 4-billion-year-old brown dwarf anywhere near the sun, it would have been spotted.
So far, no nemesis has been found.
So if there's no nemesis star out there, is something else messing with the Oort cloud?
Another idea is there could be a relatively massive planet, Earth-sized for example, orbiting way out past Neptune.
But detecting a planet that far away is much more difficult than detecting a dwarf star.
The farther a planet is from the sun, the dimmer it is and the harder it is to see. So you could have a planet the mass of the Earth several billion miles out from the sun, and it would be basically invisible to our telescopes now.
There is still a chance that something the size of the Earth might be out there, far away in the Oort cloud, disrupting things. That's the last gasp of the nemesis theory.
We may never know what's nudging Oort cloud objects out of orbit, and it's not the only mystery out there. We still don't know where the solar system ends.
Finding the edge of the solar system helps us with the bigger problem of understanding the solar system as a whole. How do you know when you have the whole solar system until you found the edge?
Perhaps the biggest mystery of all is that our sun has too much stuff. It's wandering the cosmos with more than its fair share. It's possible our sun is a thief that robbed its sisters and brothers in a cosmic wound. But that extra stuff could be our ticket out when the sun turns up the heat on us. 25 years ago, the solar system in our eyes was 9 planets and around 7 billion miles wide. Now we know it's 1,000 times larger, more than 3 light years across. And every time we look, it gets bigger. Too big, in fact. Somehow, it's got way more stuff than it should have.
Theoretically, we can calculate how many comets should have formed when the solar system itself formed. And then we can look at the number of these comets coming in from the Oort cloud and try to figure out how many are actually out there. It turns out the two numbers are way off. The number that formed with the sun is much, much smaller than the number of comets we infer are out there.
There's simply too much material in the Oort cloud to belong to one average-sized star.
The only way we can balance these two numbers is if the sun, when it was young, was a thief.
5 billion years ago, a supernova explodes, sending a shockwave through a vast cloud of dust and gas. It compresses the cloud, creating regions of dense gas, a star nursery. Hundreds of pockets of gas collapse under their own gravity, giving birth to hundreds of sibling stars.
We think our sun formed with brothers and sisters in clusters, and the sun we think formed in a cluster with 400, 500 other stars.
If you can picture these stars forming, and they're very small compared to the distance between them, but their own cloud of comets is very large. So it's possible to steal comets from each other. Well, the sun was smart, and it walked away when it was ahead. It got a bunch of comets from other stars and then went off on its own way.
Some of the stuff orbiting us right now far away could have come from those other young stars.
This cosmic sibling rivalry may still be happening now. We could be stealing objects from our brothers and sisters while they're filching from our Oort cloud.
The nearest star that our Oort cloud butts right up against the solar system of is Alpha Centauri. There's probably another Oort cloud around Alpha Centauri. Maybe there are objects that even switch between the two stars. So halfway in between these two stars is where we find the true edge of our solar system.
And what happens at the edge could be bad news for us.
Alpha Centauri could have a real effect on life here on Earth. It could be that that star and the objects around it in its Oort cloud have some gravitational effect on our Oort cloud, when something falls in that may have been due to the influence of our nearest star.
That means it's not an edge, just an endless tug of war.
We humans love hard edges. We like boundaries. But the solar system, it's not like that. It just fades away. It blends into the galaxy at large.
The sun does not live alone, and nor does our Oort cloud. We're interacting continuously, and in that way, we're connected to the much larger environment of the Milky Way.
And that fuzziness may be our ticket out of the solar system. Where the solar system ends, there might be stepping stones out, and the beginning of a new journey.
One interesting thing about knowing now the structure of our solar system is that there are many more objects that we can use for resources as we venture out into interstellar space.
There's rock out there, there's ice. We might be able to replenish our spacecraft as we go past. Maybe something as distant and tenuous as the Oort cloud will be our next jumping off place to truly explore the galaxy.
We have much to learn about our solar system, with many new surprises to discover.
Every time we open a new window on the universe, we're surprised, and that's what excites me. Every morning I wake up and I'm surprised if I'm not surprised.
And as new technologies open up, so will our understanding of what's out there.
We're building better telescopes, we're sending probes out into space. We have so much more to learn, and that's the real exciting part.
Our new eyes to the universe are showing our solar system in a new light. We are slowly piecing together the complex connections that bind it to our lives and to the universe beyond.
Every new discovery we make about the universe has told us that no solar system is an island, that material comes from outside and comes inside, and from inside goes to the outside. And so as we probe the outer edges of our solar system, we're changing what we mean by solar system.
We are taking the first baby steps off the planet and starting to look around our environment, and that's pretty neat.
The sun is like one voice in a vast chorus of hundreds of billions of other stars and their particular solar systems. And I find it very poetic that in fact we are part of a much larger population out there.
To think that we found everything in our solar system, to assume we know everything, is not the way science works. Science works by pushing the frontiers, and we continue to do so. And in 10 years, if we do this program again, I wouldn't be surprised if we talk about new things.